Hello, I'm Jason, and I work on Cisco's Developer Relations team. But I also have the opportunity to assist in the CiscoLive NOC when we have our events in the US and Europe. And as a network management guy, I can tell you we're always after telemetry and instrumentation, and I really appreciate a lot of the functionality we're putting into our products around netconf yang models, SNMP, MIB instrumentation, streaming telemetry, gRPC, and all that. It's really cool. But invariably, there are things that still exist that we have to obtain through SSH and the command line interface. I refer to that sometimes as finger-defined networking. And if you have that situation, you might ask yourself, how do I get that information out quickly? And how do I put it into something like InfluxDB so that I can use Grafana to create some cool dashboards like you may recall seeing at our Cisco Live events over the years? And what I want to share with you is a software repo that we created that we're in a project we're calling SSH2Influx. Essentially what it is it just SSHs into a device. It extracts the command that you define in a YAML file. That YAML file also defines the regular expression match that you need to run and the tags that you would associate to the influx data. And then it pushes it out to Influx for you. So you don't have to write Python code. All you need to do is know the commands that you want to run, the regular expression match, and define some of the tags in a YAML file. And you can create multiple parameters files. So let's look at this project now. And it is here on Code Exchange, which provides information about the project. And here's a picture of a dashboard we did for wireless monitoring that depended on this project, SSH2Influx, to extract the information and make it available inside Influx, which then we could use in Grafana to create a dashboard as what you see here. So you're going to need to have a Python environment and an Influx environment. Whether you use Grafana or some other graphing utility is up to you, but we chose to use Influx to drop the data into. And also we find that Grafana is pretty powerful for creating dashboards. We give you instructions on how to clone the repo and create a Python virtual environment. Then you want to pip install the requirements for this project. At this point, we get into a configuration phase, which we have two configuration files. One's called an optionsconfig.yaml, and the other one is a parameters.yaml. The optionsconfig.yaml file contains information about your environment. So let me show you what it looks like in Visual Studio Code. So we provide an example optionsconfig YAML file, and it's going to have information about your influx system. What is the host, name or IP, an alias if you want to give it one, what's your API token, your bucket and org information. Then you're going to have some authentication groups, so you can use that with your service account. That would be used to log in to the router, switch, or Linux virtual machine even. And then you have to build up your device inventory, okay? And that's where you just define your management host names or IPs, aliases if you want, and usernames and passwords. Or if you don't supply a username and password, it'll use the default credential that could be used like with AAA or something like that, right? So this is where you put your private secure information. The second file is your parameters .yaml file, and you can call it anything you want because you can have multiple job files that define the work you're doing. And I've created some examples under the examples directory, and here's one called sample single. So we have three different ways of defining our regular expression matches: single matches, multiple matches, and iterative matches. The documentation on the project goes through what each of those does. But if we're using this sample single one, you can see we've got three hosts, and we've defined the three always-on systems from the DevNet sandbox environment. And the command that we want to run on each of these is called show version, and it's going to be associated with a parsing spec or parse spec. Under parse specs, this parsing specification is defined we want to give it a measurement called inventory. So when it goes into Influx, it will be tagged as a measurement inventory. This one's a single match type, and then you define the regular expression that you need to go through the output of each device's commands, and then you define the tag types. So you can have tags that are key values that are used for sorting and filtering inside of Influx and Grafana. And then you would also have the types of key values that are fields. And these are your variable information. Could be octet counters, RPMs, watts, whatever it is that you can extract from a command. But some things you want to define as a sorting criteria could be like a building or something like that, or a region. And then the other things that you use key values for are your field key values again. And this one I'm defining as the second match will be uptime and string. I'm going to show you when we run this command manually through the device, it gives a show version output. And essentially what I'm looking for is this output. And it can be anything. It can be a string, decimal value, integer, etc. But we're just going to do a real simple example of a string compare. And using a very simple regular expression match tool, I want to grab the host name. Uptime is some number of hours and minutes, right? And so this is what the regular expression match is that I would be interested in. When I put it inside my parsing specification as the regular expression match, then the first field will be grabbed as the host name, and I'm going to put that as a tag and a string. The second field that we match on is the uptime. It is going to be a field key value and a string. Let me show you how this works. It's pretty simple. And you can create these all day long. So Python, SSH2Influx, Python script. You need to give it a parameters file. So my parameters file is in the examples directory, and sample single file. And there we go. And first thing it does is it learns the device prompts, it stores that and never asks again, and then it executes the command, and then it processes the output, and then it processes it into an Influx write protocol format, which is the measurement, any static tags, okay, and we're always going to have a device equal something be a static tag, but then any other static tags that you may have defined, like I said, the first match of host name was going to be a static tag. The write protocol defines a space between the static tags and the field key values, and so then the variable uptime equals this string, and then it pushed it into Influx, and a 204 means that we had a good data push. And now you can see that it's waiting to run this again every 5 minutes, and this will happen over and over until you do a Control-C to stop it, and it'll just keep pushing data into Influx. And that's pretty much it. Let's go see what happens when we jump over to Influx. All right, now we're in the login for Influx. If we log in, we can use the Data Explorer to find the statistics that we just pushed in. And remember, we put it under measurements of inventory, and we can see the uptime tag was found, and it found all 3 devices. And if we were to say, show me just the last statistics, and put it into a table, and execute, boom, here's one for 4 hours, 6 minutes. Here's the other one, 8 hours, 2 minutes. And here's the other one, 5 hours and 55 minutes. If we go back again, we can see that maps well to the input that we pushed over to Influx. So now you have that information in Influx. You can push it over to Grafana and create any kind of dashboards. Again, you're not limited to text fields and tables. You can do thermometers and RPMs, anything you can put as a decimal value or an integer value. I hope you find some value out of getting this SSH2Influx utility, and hopefully you're able to contribute to it too. Thanks for your time.